Hello everyone. Today is the sixth day of Leetcode 75 challenge. Let's begin with the sixth question. Question 151. Reverse words in a string. And the level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. You are given a string S that contains words separated by spaces. Okay. Your task is to reverse the order of the word as a word is in any sequence of characters that does not include spaces. It's basically a definition of a word. The input may have extra spaces at the beginning, at end, or between words. Final output should have words in reverse order, use only one space between words, remove any extra spaces at the beginning or at the end, and return the modified string. So basically, they are saying that a string could have the initial spaces and they could also have some extra spaces in between and at the end, right? And they just want a reversed string with no extra space, just one space between the character words. That's all. Let's let us understand the problem constraints. The length of the string would be from 1 to 10 to the power 4. Now, S contains English letters that could be uppercase and lowercase, digits and spaces. There is at least one word in S. Okay, there would be at least one word in S, so it won't be an empty string. Let's understand the input output of the problem. What is the input given here? The sky is blue. Fine. So here we can see that there is only one space in between, which is acceptable. So we just reverse the string as blue is sky the. Okay. Here in the second example, we can see that there is one gap here. We can assume this has two gaps. Basically, this is extra. That's all. Right? There is no gap in the end. So okay. So when we reverse this, it will come in the end. Then one space, then word, then one space, then a. So we can see that the space between good and example was two. Now it is one. So we have to basically reduce the extra spaces from the start if there is any, right? And remove the extra spaces if there is any in the between and at the end and return the reverse string. So we we understood the input and output how they are working. To understand what problem is asking, we should build up an intuition to the problem. Okay. Now imagine you are stacking books on a shelf. Okay, let this be a shelf. Now let's this be a shelf. Okay. You place them one by one. Here, here. But later you realize you need to rearrange them in opposite order. Okay. Each word in sentence is like a book. This is a word. Spaces between the words are just gaps between the books. Gaps between the self. The next book is here. Let's assume. Some gaps might be extra wide, multiple spaces, but you only need one gap between books when rearranging. Your task is to take all the books of the self and place them in reverse order, making sure there is only one gap between each. At the end, the sentence should look clean, just like a neatly organized shelf with evenly spaced books. I hope you understand the intuition, what I'm trying to say here. Now let's move to the next slide. Now, before going to the approach, let's understand what is DQ data structure in Python. So I have tried to explain what is DQ and how it works in a briefly manner. Let's try to understand here. DQ stands for double-ended queue. In Python, it is a data structure that allows adding and removing elements from both ends. We can add elements from here also, front and back, and we can remove it also. Okay. It is implemented in Python using collections DQ module. Now, what are the key features? Fast operation on both ends, better than list for inserting and removing at the beginning. Okay. Supports append, pop from both left, which is append left and pop left, and right, append and pop. That's good. So we can see the example here. This is a DQ. Now we appended 4. What will happen? It will be appended at the end. So it will become 1, 2, 3, 4, right? Now we append left 0. It will be appended here. Okay. Now we have to remove elements. DQ dot pop. It will remove this element from back 4. Pop left will remove first element from the queue. And if we print, we get 1, 2, 3 as the output, right? So when to use DQ? When we need to uh, have a fast insertion or deletion at both ends, it is ideal for queue and stack implementation because in if you understand in Python we don't have a stack data structures out of the box like we have in C++. So we will be using DQ as a stack in our approach to solve this issue. Now, in approach, since we get the intuition of the problem and the concept of the problem, the data structure which we will be using, let's look into the approach, how we're going to solve it. Now, before everything, we have to store it somewhere, right? As we discussed about the DQ. So we will create a DQ to store the words. Okay. Now, question is here, why we are using DQ itself, right? So I will answer that question a bit later in this part. Let's be with me. Now, we will place I equals to 0 to iterate over the string. Okay, that's good. That's a simple declarations of DQ and I. If there is any leading spaces, we have to skip it, right? If there is some leading spaces and there is a word here, we have to skip these spaces, right? We don't want this. We want the word from here. For that, if s of I is space, if s of I like this is equals to empty space, we will just do I plus plus. That's right. Find the word, first character of the word. Now, if uh, if it is not a space, right? We have encountered a character. So what we're gonna do? When a word starts, it initialize an empty string word. Why? Because a word may continue from here to some extent of length x. Fine. So we will store that complete word in a new string. Fine. Now keep adding the characters to word until a space is found. Okay. So since there is we resolve this issue of the spaces in the beginning of the word or the of the sentence. Now we got the word in between, right? So we want the complete word. So we store it in a string until and unless there is another space. Yes, because as soon as the new space we encounter the new space, it means the word searching of the word or fetching of the word is complete. Fine. Now we have what is the second thing? We have to reverse the word, right? Here I will explain why we are using DQ. Now, if you take the example of stack, stack follows what? Last in, first out, LIFO, right? So if we had one A, B, C, consider this as words, okay? Not as characters. Let's consider this as words. Now, if we pop the elements, what we gonna get? C, B, A. What is it? It is a reverse order of the sentence, right? Now, since we don't have stack out of the box in Python, what we gonna do? We're gonna use a DQ here to resolve our issue, right? So how we gonna use DQ here? We're gonna put every word in through the front side. Let us consider A as a word. We add it here, right? Now we got another word. We have B here, right? What are you gonna do? We will remove. We're gonna push this A here, and we will add B here, and so on. We will keep on adding the words in the beginning of the queue. So at the end, we're gonna get a reverse word itself within the queue, reverse sentence within a queue, right? Look, we are appending the word from the front. This ensures that the words are stored in reverse order without processing, without extra processing, right? We don't have to do any extra process because of it, right? So yeah, so up to step 2.3, what we have understood, why we need DQ, why we have initialized I as the variable, right? Now, if there is any leading spaces, we're gonna skip it. If we encounter a word, we're gonna iterate that word until and unless a new space is encountered, right? Okay. Now what? Now, if this is a space encountered, again it will go ahead. Again space, skip. Again space, skip. So this is also this loop will also ensure that if there is if there are multiple number of spaces between two words, we're gonna skip it until and unless new word is or new character is encountered, right? And this way we're gonna skip the last spaces in the sentences, right? If we have multiple spaces at the last and there is no word after that, So it will keep on skipping this, and we will reach at the end. And this way, we're gonna ignore all the unwanted spaces from the between, front, and at the end. And we will keep on storing the words from the beginning into the DQ so that we get directly a reverse order of the sentence. We will just join the stack or the DQ to join our words with a single space and automatically handle extra spaces, and it will return it. So yeah, this was our answer, or we could say approach to the problem. I hope you understand my intuition and the approach what I'm trying to explain here. Now the code is the exact copy of the approach discussed. Let's understand it line by line. First, we're gonna take the length of the string, which is the most important thing. Now we will initialize DQ with the name of stack because we're using DQ as a stack only, and initialize I as 0. Now in I, while in the while loop, while I is less than n, we're gonna iterate. As I said, if we find any blank spaces, we're gonna skip it, right? If it is not, we'll initialize a new what you gonna say variable word, and we will keep on adding the word until and unless there is no extra space encountered, and increment the I. And when this while loop ends, we're gonna append it to the left side of the queue or DQ, which is basically front side. And at the end, we will return using the join function. Now time complexity will be O of n. Why? First of all, we are having a while loop of n size because n size. So here we're going to iterate n times, right? And space complexity is O of n because we are using a DQ, which will be also of the not approximately of the size n, as we're going to ignore the extra spaces which we had, right? So that is why we have space complexity of approximately n and time complexity of O of n. Now, since we have the understanding of the code, let's look at the dry run of the example. Now let's take our code which we have understood, right? Let me write the example here. A good, there is one space, two space, a good example, right? Okay, I is here. It's a word. Yes, it is a word. This is the word variable which we will create, and the word will be added here. And I plus plus. I will come here. I is less than n, right? And I is not equals to space according to our code, right? But this condition fulfills, but this fails. So we're going to come out of the while loop, right? And we will append the word A into our DQ here. Great. Now again, I will come here. G, we encountered a new word again, right? So we're going to iterate this whole word one by one character, and store it in the word variable word. And since we encountered again one more space, we will come out of the loop. I'm talking about this loop right now, this loop, and we will put it into our queue from the front side. Let me remove this. Okay. Here, good. Okay. Again, it will come here. Since it's in a space, it will increment the I value. Again, we will come here. Okay, now we have encountered another word. So we will iterate this word, store it here, and we will push it to our queue from the front side. Example, right? This is done. The loops ends, and we have a DQ of this sentence. And we will use uh, join function to make it as a string and return it. So yeah, this is how our code works. I hope you understand the dry run of the problem. Now, since you are familiar with the problem and solution, let's move to the lead code and code the solution. We will declare n and length of s stack equals to dq. initialize I to 0 while I is less than n if s of I equals to space I plus 1 and continue, right? Else we'll initialize a variable word with empty string so that while I is less than n and s of I is not equal to an empty space, we'll keep on adding the characters one by one to the word variable, and when the condition fails, stack dot append left word, and when the while loop ends, we will return by joining the string. Okay, stack. Let's run the solution and see. So we passed these three test cases right now. Let's try submitting the solution. So yes, we have submitted our solution successfully. Now, code of the problem is available in my GitHub repo. You can find link in description. Thank you everyone.